my presentation about my favorite ClickHouse features. Not about all of them, because there are so many features that it will be difficult to tell about everyone, but just about some selection of my favorite features for the first half of 2024. So let's start. We have a few features for data processing, and the first one is refreshable materialized views. When you look at this query, it can look quite complex. So you can create materialized views, but a special kind of materialized views with a refresh statement. And you can specify how frequently to refresh, time randomization, dependencies of this view, and finally, the select query. What is it for? With refreshable materialized views, you can run queries periodically in the background and atomically replace some table with the result of this query. So it is actually simpler than regular materialized views, because with regular materialized views, you can do incremental aggregations. You can incrementally transform your data. And this is simpler. You just fully refresh your data in the background. You can do something like pulling the data from external data sources, importing data from MySQL, Postgres, Mongo, whatever outdated databases you don't have to use anymore, and import this data into ClickHouse. You can do some complex query transformations, data pipelines with dependencies, and it just works. It is so nice. Let's take a look at another one. Another feature is named S3 what it is. So let's imagine you have a bucket on S3 or GCS or any S3 compatible storage on Minio or whatever. And you have a bunch of files, and new files just appear in this bucket periodically. By the way, if you use Cloudflare, you can define Cloudflare log push, and the files with logs will appear on S3. And a lot of systems work this way. And you want to consume this data incrementally into ClickHouse. Now it is easy. You create a table with type S3Q. You create a destination table. And you create a materialized view. And after you create a materialized view, it will automatically subscribe to this bucket and import the data with this query. It looks similar to the existing Kafka table engine, but the difference is you don't need to use Kafka. OK, let's take a look at some example. So in this example, I have some bunch of logs in S3, and these are spot prices in spot prices feed. So we use auto-scaling group for our continuous integration system internally for ClickHouse. We use spot instances, and we do want to know how much did it cost. We use a lot of instance types, and this data is provided by AWS. We can subscribe to it. And it will appear in a bucket that we configured. In this example, we use the line as string format. It just imports everything as a string. And to preview this data, I am using a simple select from S3 table function. So here is a preview. But it is not convenient to store everything as a single string. So we can just process this data, extract what we need to extract with this select query. I'm extracting the time, the instance type, the price, actual price, market price, the number of hours, etc. And in this example, I'm just reading it once from the S3 table function. So it looks easy. But the same query I can plug into the new S3Q table engine. It looks like this. So I'm also creating a destination table. And S3Q will just import everything as TSV. And the insertion into destination table will process this data. To observe how it works, there is a system table named s3q log. And when I created the materialized view, it also just works. It is amazing feature. It is simple to use, easy, and nice. OK. The next feature is about type inference. I already presented about type inference a year ago. And here I want to present some enhancement for the type inference. So the main point that it works for arbitrarily nested JSON. Here you can see some arbitrarily nested JSON. But do you know how long it will be if I will scroll down? It will, let's scroll down. So it goes and it continues. I don't even have a progress bar. How long I will have to scroll? And it is not a multiple objects. It is just a single record, single JSON object about something. SSL certificates. It's very complex. But I have to scroll it just to show how long it is. I don't know. I forgot how long it is. Where?
Yeah, it's a little white bar.
Ah, OK. So it is not so desperate. I'm scrolling, and this is just a single object. And I don't have to define these data types in my table. They are inferred automatically when I create a table from this example data set. So let me take a look. What is the data type? What is the table structure created? So let me do it again. It goes. So it contains some interesting data types. A tuple, named tuple with nested fields, and some of them are another nested tuple, and there is another nested tuple, and another nested tuple. And I can actually import this data into a table. I can also read it as is. And to read it as is, I will use a very simple notation with dots. Data.tls, .results, .handshake, .server certificate, parsed, issue, organization, number 1. And everything works. OK. It is just about the type inference. And yeah, it works if I just select from URL. If I create a table as select star from URL, the structure will be inferred from this URL table function, and it will propagate to the create table statement. So I don't have to specify it here. I am just skipping this table structure. And by the way, even data formats are auto-detected. So here I inserted from some file .json.lz4. So it is obvious that this is JSON data. But in this example, I have a bunch of files, data 1, data 2, data 3, and each of them is in its own format. In one example, it is JSON. In another, it is CSV. And in the other example, it is TSV. And it is also inferred automatically, even if there is no file extension. Oh, OK. What else? So what about new data types? We have a few of them. The first one is named variant. Variant is like a discriminated union. you specify variant, and inside the parameters, you specify options. And here are 3 options of data types that it can store. And when you have this data type, you can insert any of the options plus null. So all variant values are also nullable for free. In this example, I'm inserting null, 42, string, and array. And when I select it back, it works. It also works for the conditional operator. Before the variant data type was introduced, if I was using this conditional expression with a string inside one branch and integer inside another branch, it did not work. Now, if you enable this feature flag, it works and gives you the variant data type. It also works for creation of maps and arrays. So you can have a map mapping to a variant. You can explicitly cast to the variant. And if you have a variant data type, you can cast it to a specific data type. And there is another operator with the dot operator. Instead of casting, you will be reading a particular value if it was of this data type. So in this case, I am reading only the string subcolumns, and I'm skipping the other subcolumns. And this is the most efficient way. But if you just cast to a string or cast to an integer, it will work like schema on, maybe you can imagine it like schema on demand. And it works with for insertion from various data formats, including JSON. So here I have a JSON with non-uniform data types: strings, integers, floating point, date, and array. And this data is inserted. But OK, there is one enhancement for this data type, a new dynamic data type. So the dynamic data type works as unrestricted union. The variant data type requires explicit specification of nested data types. The dynamic data type will accept anything. You can insert anything into the value of dynamic data type. So let's take a look how it works. Here I am creating a table with a single column of type dynamic, and I am inserting whatever, arbitrary garbage, no, not garbage, precious data into this column. And then I'm introspecting it by selecting it back, and I'm also introspecting its real data type. The same, I can also cast anything into the dynamic data type. I can cast it from the variant column, and I can read subcolumns with this syntax. I will read only the data of particular types. And the main point is that this expression, this query, will be as efficient as if you have this explicit column of a string data type. There is no overhead at all. Different data types are stored in a different subcolumns. And if you read it like this, if you are selecting a subcolumn, it will read only required data. So the format is column-oriented. It is as optimal as it could be. And finally, it works for any data formats. It will insert anything from JSON, CSV, TSV into the dynamic column. And what is it for? The previous two data types are building blocks for the new JSON data type. This is the latest addition in the version 2024.8. And the JSON data type can accommodate arbitrary nested data with arbitrary types. And you can use it as simple as here. Just specify a column with type JSON. You don't have to specify any parameters. But if you want, you can specify some subset of JSON path to skip, including regular expression filter. You can specify type hints if you know the types better, then ClickHouse will automatically infer. And you can specify some limits. But don't worry about these limits. Even if the number of distinct paths in JSON exceeds this limit, it will just fall back to a slightly less efficient implementation. It's like the first 1,000 of columns will be stored separately, and if you have more, they will be collected together and still stored successfully. Let's take a look. So when you insert JSON, ClickHouse will analyze it. It will infer data types for every unique path and store every unique path and every distinct type in a subcolumn up to the maximum number. So it enables you to store semi-structured data like arbitrary logs, user-provided parameters that you don't know in advance, API responses. If I'm querying some service and it responds me with JSON, I can spend 2 hours and analyze which types will be the best, but I can be just lazy and define it like payload JSON, and it will work. Okay, let's take a look. It works for inserts. You can insert from a JSON each row format. You can insert a string, and it will be interpreted as a JSON data type if it contains JSON. Like in this example, here is a string containing JSON. And in this example, I'm inserted it directly from a nested object. And to analyze this nested data, I can use a usual syntax with dot notation. Here I'm extracting nested subobject A and a field B, and I'm casting it to uint32. There is a new operator, meaning instead of casting, just extract only the values of int64, like in this example. It looks like dot colon, a new syntax. If there is a sub-object, you can read the whole sub-object back and reconstruct the original JSON. And here is a new operator. Don't be surprised. It is a new operator. Dot, how to name it? Caret. Here should be a demo, but probably I will skip this demo. Let's take a look at another interesting feature. What about query processing? The main thing for query processing is releasing analyzer in production. So how many of you already know what is analyzer? Please raise your hand. 1, 2, 3, 4, 6. You should know. Only 6 people. I'm just a bit disappointed, but let me explain. Analyzer is a new infrastructure for query analysis and optimization. It unlocks many possibilities to optimize queries. It already gives benefits in compatibility. Some queries just did not work before we introduced Analyzer. And you do just a small setting change. You enable Analyzer and your queries magically works. And mainly it applies for queries with complex joins, with a lot of dependencies in names. For example, it was not able to write a query with multiple array join operations. There is a special kind of join named array join. Now it is possible. And it was a 2 years effort. It was introduced 2 years ago in version 22.10 in the experimental stage. This year in 24.3, it was declared beta. And recently, we analyzed the usage of queries in our production. We fixed all the remaining bugs, all the remaining incompatibilities. And now we enabled it by default for all new services in ClickHouse Cloud. And since the latest release, it is declared production ready. It is production ready in the cloud, production ready in open source, so it is battle tested. And now please enjoy the new analyzer. One small thing that it also enables is recursive common table expressions. You probably, if you use Postgres, you're probably familiar with recursive table expressions, but it is quite advanced feature. So you have a subquery that references to itself recursively. And in this example, this subquery will union with another query. And this union, it will be continued as a chain of subqueries until the subquery will stop returning new data. And with this feature, you can analyze tree data structures, graph data structures. And to test this feature, we just looked at the test suite from Postgres. We imported it and make it working. And actually, it works even better than in Postgres. Because, for example, this query to analyze a tree data structure, for some reason, it does not work in Postgres, but it works in ClickHouse. OK, I have even more features. It is so difficult to select my favorite. Maybe some of these boring security features will be my favorite. The first one is the possibility to define temporary user credentials. So when you create a user, you just specify their credentials will be valid until certain time. You can use it as a tokens. So you create a user with some temporary name, temporary password, and you define something like this. User will be valid for just a single hour. And so it is basically a temporary token. And you don't have to worry if you want to import data or export into other system just once. And you will have to delete this user later. Now you just create it with temporary credentials. Another boring security feature is authentication method with SSH keys. So instead of using a password, that is quite not fashionable today, I would say, because the password can be compromised, you have to type it and so on. Instead, you just use your SSH key. And as you know, your private SSH key remains on your machine, and you only configure the public SSH key on the ClickHouse server side. So it is pretty nice. It is not going to be compromised. And it just works as usual. Another interesting feature is advanced access control for views. let's imagine a scenario. You have a table with a lot of data. And you create, we can say data mart or data catalog. Let's just say a view. It is easier to say. You create a view representing a subset of this table. And you want to give a user access to only this subset of the data. Until recently, it was not possible because the access control was very strict. It was checking access to the view, and you had to give access to this view. And it also checked access to every underlying table when this view, select from the view, was processed. It was strict, but it was implementing not exactly what you wanted. Now it is possible to use this. You can define SQL security with a definer. And basically, it is encapsulation of access control inside the view. So you create a view and like package your own access to this table inside the view. And then you give access to this view to another user. And another user will query this view. And the view will query the underlying table from the context of the original user. Maybe it sounds complicated, but it works just as expected. You define you define the definer, which could be the current user or a specific user, which access will be encapsulated inside this view. And you define the SQL security that could be either definer, it means who created the view, or invoker, it means who is making the select query, or none, it is like a special case for materialized views. And it serves the purpose. I would say this feature is particularly boring, but if you actually need this, you will be happy that it exists. Okay, what about something else? Less boring features. The new Kafka engine. There is a Kafka engine in ClickHouse, and guess who introduced the Kafka engine originally in 2016? Which company? Absolutely correct. Marek from which company? Exactly. Marek from Cloudflare introduced it in 2017. And it is just an amazing feature. It serves so many usage scenarios. It works almost perfectly. And for some reason, we had to rewrite it. It has one small downside. The commit to ClickHouse, so insertion into ClickHouse, and committing the offsets of consumed data into Kafka was not atomic. And it was possible to get duplicates in case of retries, especially if Kafka itself decided to do rebalancing. Many people did not even worry about this small downside, because if they import some logs, it is only important that the logs was recorded. And duplicates don't matter. But some scenarios required exactly once insertion. So in the new implementation, we don't even bother to notify Kafka that we have read this data. We don't let Kafka know about this. Instead, we store offsets in Keeper, in our own Keeper. And we store also the intention which chunk of data we are going to read from each partition. So in case of network interruptions, in the case of server failures, in the case of Kafka rebalancing, in any case, if something failed, we repeat the same attempt to insert data from the same partition, exactly the same chunk of data. And if it was inserted before, it will be deduplicated. So it makes the consumption exactly once, finally. After how many years? After 7 years, we have fixed this problem. And one more, the new time series engine. So we thought, what if so many people are using Prometheus? But do I like Prometheus? Do you like Prometheus? It's actually pretty nice query engine, pretty nice set of integrations. It is quite convenient. But what is wrong with Prometheus is its storage. What if we will replace Prometheus storage with ClickHouse? So in the latest version, we have an experimental feature named time series table engine. You create a table engine without any table definition, just like this. The engine is named time series. And under the hood, it will create 3 tables. A table for the time series data itself, the table with a dictionary for tags, and the table with a metrics dictionary. Then you can configure it to usage for remote read and remote write protocols. And Prometheus will write data into ClickHouse, and when you do PromQL query, it will read data back from ClickHouse. It allows some customizations, like you can take some tags and put them into separate columns. It is reasonable for tags like host name, service identifier, customer name. You can adjust primary keys. You can adjust types of the columns. And ClickHouse will listen to the Prometheus protocol. We still have some things to do. Like I really want to implement PromQL. So there will be, like you are using Prometheus, but there will be no Prometheus. How nice. I want to use ClickHouse for everything. Okay, probably one more. I forgot how many features do I have. Asynchronous loading of tables. So if you use ClickHouse with thousands, tens of thousands of tables, by the way, let me ask you, how many tables do you have in your cluster? Dozens. This is good. Actually, this is a good use case. Okay, perfect.
There's an upper limit because then loading them on start takes a long time, so limit it.
This is absolutely correct, but not everyone is so smart. So who wants to present? 14,000. It is quite okay, I would say. At least not 100,000. Okay, but if you have at least 10,000 of replicated tables, the server will take a long time to start up. Now with asynchronous loading of tables, the server will start up instantly and instantly start loading these tables. But when you query a table, if it is not loaded yet, the query will just wait for loading. So if most of these tables are not instantly used after startup, it will save the time. The server will be available earlier. Yes, the server will start instantly. Sometimes you don't want this behavior. You want the server to be ready for queries with all of the tables. Then just don't enable this feature, right? It is fine. And probably one more. It is, yeah, about asynchronous insertions. So there are many, I would say, misconceptions about ClickHouse. Not actually misconceptions, but probably old wisdoms. One wisdom tells you, like, don't insert data record by record. Always collect it by batches. But it is not longer true. You can enable asynchronous inserts. And then, even if you insert data record by record, or just a few records, with hundreds and even thousands of concurrent clients, these records will be combined in the background together, inserted as a single batch, and it is also safe by default. So the clients will receive a confirmation when the data is actually inserted. But it requires some time to accumulate this data into a batch. And in the previous version, this time was defined as a like a constant threshold. You can change this threshold, but it is just constant, like 200 milliseconds. In the new version, it is adaptive. When you do a single insert rarely, it will not wait 200 milliseconds. When you do it from many concurrent clients all the time, a lot of inserts, it will increase this delay just to collect these inserts together. So the main point is you can enable asynchronous inserts by default and don't worry about the latency. If you insert by batches, it will work as good as before. One more feature. chDB. Does anyone use chDB? Okay. 3, 4. Nice. Okay, slightly more. So chDB is like ClickHouse engine, full-featured engine inside your Python script. You will get all the power, all the data sources, all data formats, all query engines, everything. The best SQL dialect in the world, ClickHouse SQL dialect, all inside your Python script. It even you can even process Python objects and pandas data frames. You can even define Python code as user-defined functions and reference them from the SQL language. So it is quite a feature.